Okay, YouTube, this is a follow-up my last video where we looked at the definition of radian measurement. In this video, we're basically going to go ahead and continue to look at converting between degrees and radians to degrees, but also kind of understand that degree and radian measures, there are some special angles that we constantly are looking at here. And so what you are seeing here is a bunch of different common degree measurements. And you can see that, we have a 30, a 45, and a 60, which occur in our, 30, 60, 90, or 45, 45, 90 triangles. But also that all of these over here in these other quadrants here, this is kind of like 150 is 30 degrees shy of a 180, and then we say 135 right here is 45 degrees shy of 180, and we say 120 here is 60 degrees shy of the 180. So everything else you're seeing in this unit circle here, I'm not going to call it the unit circle, but a circle here, these common measurements have 30, 45, and 60 degrees, what we're going to call in the future reference angles. And so looking at these increments, you'll see that on the outer edge of this circle, we see the radian measurements. And so I'm going to basically start with a very, very common radian measurements. And those are the measurements that 2 pi is the same as 360 degrees. That's a very common thing. And we also see that very commonly pi is also related to 180 degrees. And so I always recommend that when people are sketching or interpreting angles in radian measurement, you start by kind of recognizing those. Also that this top angle here is half of a pi or half of a 90, so we say pi halves. And then down here we would say that this pi halves here, if we were to rotate pi halves and then 2 pi halves, which I'll actually write right here, 2 pi halves would be 2 90s. That's the same thing as pi. That's why we just write pi. And then we rotate down here to 270. This is the same thing as 3 pi halves. And so we say 3 pi halves is another very common measurement down here. And then we get over to 2 pi, which would also, I'm going to write over here, be the same as 4 pi halves, or 4 90-degree rotations. And so all of these rotations you're seeing here, what we're going to do is we're going to come up with a couple of different sketches off on the right. And I say that this is always just kind of very convenient when you're learning this. We're going to draw a couple of circles, and in this first circle here, we're going to look at a circle that is partitioned into 8 different pieces. And so with this 8 different piece partition here, let's go ahead and do this. We say 1, 2, 3, 4, 5, 6, 7, 8. We have these 8 pieces here. What we're seeing are pi force increments. And so pi force, which is half of a pi halves, and pi halves of course is a 90. It's a good one to know. We say pi force here. 2 pi force is what we could put right here. Now I want you to understand that as we label these 2 pi force, we'd say this is 3 pi fourths and 4 pi fourths out here. You're seeing that we don't often label all of these exactly what they are. So for instance, 2 pi fourths is the same thing as pi halves, and we usually just call it pi halves because it's reduced. So 4 pi fourths, we have 5 pi fourths, is 6 pi fourths. It seems my unit is lagging a little bit here, I apologize, and then 8 pi fourths. So for this last one that we're going to draw here, we're going to draw another circle. This is the one that I'm not particularly fond of doing, but it's good for us to do, is we're going to split this total 2 pi rotation into 12 different parts. And so what we're going to see is, I'm just going to say it here, in terms of degrees are like 30-degree rotation pieces. Okay, so we have 30, 60, 90. We got 120, 150, 180, and then we got 30 past that is 210, and then we had 30 past that is 240, and then 270, and then 300, 330, and 360. But in terms of radians, what we're going to see here is this. We have pi sixth. Now the interesting thing is that when you get to here, we get 2 pi sixth. But that's the same thing as what we see as being a pi third, or a third of the way rotation all the way over to what we normally call pi, which is 180. So as we keep going around this, we're going to see that this is like 3 pi sixths. Okay, 3 pi sixths is the same thing as pi halves, but of course it is. And we say 4 pi sixths, 5 pi sixths, and then this here of course would be 6 pi sixths. So what we're going to look at a lot of the time is essentially something where a lot of these can be reduced, but they make sense to read aloud. Like 4 pi sixths would be 4 30-degree rotations, and we could reduce that to 2 pi thirds afterwards. So these are all these measurements you're seeing here. And many of these that you're seeing here are all reduced. So let's go ahead and take a look at, say, these examples down here where we're going to convert from degree to radians or radians to degrees. But let's go ahead and start with our 135-degree angle. Now, when you consider 135 degrees, we can go ahead and look at this here. I'd say, well, this is 90. and this is 180. You know, it's kind of already good to know that 135 degrees is kind of like smack dab in the middle of those. So here's our 135 right there. But the question is, like, how many radians is this? So if you're a savvy consumer of radians, you know that, in radian measurement, this one that we split up into 8 pieces up here, 135 degrees would be like 3 of these initial pi fourths pieces. So we're going to get 3 pi fourths intuitively. Now, let's numerically get this. So we'd say 135 degrees. If we want to convert this into radians, what we're going to do is we're going to multiply this, okay, by pi radians over 180 degrees. And so 180 degrees, the first thing that happens is our units of degrees cancel out here. This is over 1. And then I'd say that 45 is a factor of each of these. So 45 goes into 180 degrees 4 times, and it goes into 135 degrees 3 times. So multiplying straight across here, what we end up with is that 3 pi fourths that we did indeed expect that we were going to get in the first place. Now, looking at something like 5 pi fourths here, I'm going to skip over to this radian measurement here. 5 pi fourths, if we were to sketch this, of course, pi fourths, again, going back up here to this original split up into 8 piece, pi, we would say that would be 5 of these 45-degree angles. And so we're going to get some angle that terminates down here in the 3rd quadrant. But looking at this, we say foreshadowing. We know we get an angle that, let me find my cursor here. We get an angle that terminates down here. It's, it's 5 pi fourths-ish. What we're going to do is we're going to take this times, instead, 180 degrees over pi. And so you'll notice that our pi's cancel out here. You don't have to have a pi, but they certainly do cancel out. And we end up being in degrees. Now this 4 and this 180, 4 goes into itself 1 time. 4 goes into 180, 45. And this is in degrees. So we have really 5 45-degree angles, which is what we clearly stated, but we'd say that's a 225 degree angle right there. So now for this last one, I just kind of want to explore this negative 6.28. The interesting thing is there is no degree symbol. So this must be in radians. It is accepted as being in radians if there's no degree symbol. And so what we're going to do is we're going to take negative 6.28, and on a calculator, we'll just go ahead and grab a calculator here. We are going to multiply this by 180 degrees over pi. So we say 180 degrees over pi. And so with our calculator here, we're going to say, let's take our 6.28, which is negative, mind you. Let me get that, 6.28 negative. Well, that's what it wants to do with it. We're going to take this times 180. We're going to round anyways. And then divide that answer by pi. So this is roughly like negative 360 degrees. So that's what we wanted anyways, is negative 360 degrees. But approximately negative 360 degrees. And the conversion factor, remember, it always works so long as you've arranged it correctly. Cheers.